Question 34. On a test that has a normal distribution of scores, a score of 57 falls 1 standard deviation below the mean, and a score of 81 is 2 standard deviations above the mean. Determine the mean score of this test. So they're talking about normal distributions and means and standard deviations, and they're talking about the bell curve. I prefer to draw one, but you don't have to. All right, so the mean is the bar in the middle. Then you have standard deviations. You have 3 above, and this is +1, +2, +3, and then you have 3 below. -1, -2, -3. So when this says that you have a score of 57, I'm going to get a highlighter. When it says a score of 57 is 1 standard deviation below, that means you're at this line. And then when it says that a score of 81 is 2 standard deviations above, that means you're at this line. So the question wants to know what's the mean of this test. Well, you have to know that standard deviations mean it's the same number. So something's getting added to here. Let's call it X. And something's getting added the same number to here. And something's going to be added again the same number to get from 57 to 81. Now, you can guess and check. You could do 57 plus 3 plus 3 plus 3. And if that doesn't work out, then you could try 4, etc. If you are going to do the guess and check, please show your guesses and your check. But in front of my face, I can actually see what I'm trying to solve for. I'm trying to figure out 57 plus what number 3 times adds up to get up to 81. Again, this is a formal way to do it. You could most certainly do it without setting up an equation. But basically, you need to subtract 81 and 57. And get 24, and then divide out 3 jumps. So that means each jump is 8. So now I know what I'm adding. We're adding 8. So if I add 8, I get to 65, and I can check it. If I add 8, I get to 73, and if I add 8, I get to 81. So it does check out, and they want to know what's the mean. So the mean is the number at that bar, so the mean equals 65.